So we're on page 70. We're going to continue with examples, and we're going to actually do examples which involve applications of using quadratic equations. So we're going to do this example number 4 here. Then we're going to introduce the Pythagorean Theorem, right-angled triangle. We're going to look at that and show the formula of the Pythagorean formula. And then finally we're going to apply the Pythagorean formula to example number 5 here. So let's get started and look at example 4. And we're told here that the sum of the squares of two consecutive integers is 41. Find the integers. Now, when we say two consecutive integers, we're talking about whole numbers. So 4 and 5 would be consecutive integers. 22 and 23 would be consecutive integers. So if we identify the first integer as x, then the second integer, or the next one, the consecutive one, is x plus 1. So we're told here the sum of the squares of two consecutive integers is 41. So the first one is x, and we square it. The next one is x plus 1, and we square it. We're told that this sum is 41. Let's go over that again. The sum of the squares of two consecutive integers. So we let the integers be x, and the next one is x plus 1. Then we square the x, and we square the x plus 1. So we get this. So this x squared is this x squared. Now we use FOIL on x. This is x plus 1 times x plus 1, in which case we get x squared plus 2x plus 1. 2x comes from the fact that we are, the sum of the inner and the outer is 2x. Okay, so this is a perfect square. We've done that before. So we have 41 and 41 here. So now what we're going to do is sum like terms. We've got x squared plus x squared is 2x squared. We have this 2x, which is this. And we bring the 41 from the right side to the left side. It becomes minus 41. Minus 41 plus 1 becomes minus 40. So we get this equal to 0. So we now have it in the standard form ax squared plus bx plus c equals 0. So just to repeat that last little bit, we took the plus 41 on the right hand side, transposed it to the left, minus 41, added the 1, and we got minus 40. Now, we can just take out a common factor 2 here, divide both sides by 2. So 2x squared divided by 2 gives us x squared. 2x divided by 2 gives us x. And minus 40 divided by 2 gives us minus 20. And 0 divided by 2 gives us 0. So now we have the simplest form, and this can be factored as x plus 5 times x minus 4, because first of all, the first times the first gives me the x squared, plus 5 times minus 4 gives me minus 20. The inner term is plus 5x. The outer term is minus 4x. So plus 5x minus 4x gives me plus x. So this factors into that. So we factor. Now we use the 0 factor property. We set x plus 5 equal to 0 here. X is equal to minus 5 if I transpose the plus 5 from the left to the right. And here if I transpose the minus 4 from the left to the right, I get plus 4. So the two possibilities are that x equals minus 5 or x equals 4. Now, if x equals minus 5, we go back here, the next consecutive number is x minus 5 plus 1, which would be minus 4. So the two consecutive numbers are, one possibility is x minus 5 and x minus 4. Now, the other possibility is that if x is equal to 4 right here, 4 plus 1 is 5, so 4 and 5. Now you can just look that if you square this number, okay, you get 25, okay, and you square this number, you get 16, and the sum is 41. So minus 5 squared plus minus 4 squared is 25 plus 16, which is 41. That makes sense. 4 squared is 16. 5 squared is 25. 16 plus 25 is 41. So we have these two possibilities, either minus 5 and minus 4 or 4 and 5. Now let's go to the Pythagorean Theorem formula, and this deals with a right triangle, and you can see this little square here. This indicates that this angle is 90 degrees. And we always deal, the longest side in this right angle triangle is the side opposite the 90 degrees angle. So C is the longest side. And the Pythagorean formula says that if we take this squared and this squared, the other two sides, it equals the sum of a squared plus b squared equals c squared. So the hypotenuse squared is equal to the sum of the other two sides. C, let me repeat that, is the longest side. That's the side which, if we square, equals the sum of the squares of the other two sides. So you only need to identify the longest side. And the longest side, we put this little notation here, means 90 degrees. Now the way to look at this formula, an easier way maybe to understand it, is to say, okay, I've redrawn the formula, I've redrawn the triangle here. Here's the right angle triangle right here. So there's the 90 degrees. C is the longest side. A and B are the other two sides, which what we label A and B doesn't really matter. I could have labeled this A and this B. It doesn't really matter. What's important is to understand that you must identify the longest side. And that side is always the side opposite the right angle triangle. Let's say that C is 5, and we construct a square on this side where this is 5 and this is 5. So it's a perfect square. So the area is 25. Now we go over here, and let's say that B has a length of 3. And I make a square on this side where this is 3 from here to here, and this is 3 from here to here. So it's a perfect square, so the area is 9. On this one, on A, let's assume, and there's an error here, I'm going to correct that just right now. I'm going to put here, sorry about that, A is 4, okay. So if A is 4, this length is 4, and this length is 4, then the area is 16. Notice that 25 equals 9 plus 16, which is what Pythagorean Theorem says. The square of this, 25, equals the sum of the squares of this and this. So if A equals 4 and B equals 3, then C must equal 5. That's another way of looking at A squared plus B squared equals C squared. 4 squared plus 3 squared equals 5 squared. 4 squared is 16. 3 squared is 9. This is 5. So that's just another way. You can just memorize the formula if you like. This is a way of understanding it because this represents what is actually happening. Longest side 25 here. The area here is equal to the sum of the area of this plus this. Now, it doesn't necessarily have to be c equal to 5, but if it's a perfect triangle, whatever the area is here, let's say this is another number. Let's say it's c equals 20. Whatever the squares, whatever the area is here, and the area is here, it must sum to this area. Of course, the proviso always is that this is 90 degrees. So let's go and look at an application of this in a problem. And here we're told, find the lengths of the side of the triangle to the right. So you can see here what we're essentially asked. We're given a right angle triangle. That's the notation right here. This is the hypotenuse, the longest side. And these are the other two sides, x. So we're asked to find the lengths of the sides. Now, we know that if we take this squared and add it to this squared, it should equal this squared. And that's what you've got here. X squared plus x plus 2 squared equals x plus 4 squared. And that's the Pythagorean theorem. This is the longest side. This side squared must equal the sum of the squares of this plus this. So now, if I take this basic formula, and this is this, and I use FOIL, x plus 2 times x plus 2, I get x squared plus 4x plus 4. And x plus 4 squared is x plus 4 times x plus 4 gives me x squared plus 8x plus 16. So I've expanded x plus 2 squared by multiplying x plus 2 by itself, and I've expanded x plus 4 squared by multiplying x plus 4 times itself. Now, if we do this, we've got x squared plus x squared is 2x squared, and I bring this and transpose it. 2x squared minus x squared gives me x squared. So if you like, this x squared could cancel with that x squared, and then I'm just left with an x squared. Now, the 4x here, I've got a plus 8x here. I bring that to the left. I have minus 8x. Minus 8x plus 4x gives me minus 4x. And I bring the plus 16 to the left. And minus 16 plus 4 gives me minus 12. So really what I'm doing is I'm collecting the terms. Here I've collected x squared plus x squared here, and it gives me this on the left-hand side. The 4x plus 4x, this goes over to the left, becomes minus 8x. Minus 8x plus 4x gives me minus 4x. And plus 16 on the right becomes minus 16 on the left. Minus 16 plus 4 gives me minus 12. And now I have it in the standard form, ax squared plus bx plus c equals 0. I can factor this. The x times the x gives me x squared. The minus 6 times plus 2 gives me the minus 12. And minus 6x inner term plus 2x outer term gives me minus 4x as my middle term. So the inner and outer give me that. Now, if you choose other factors, for example, if you choose plus 6 and minus 2, you will get plus 4x here. So that's no good. You can't use 4 and 3 because you can't combine 4 and 3 as factors of 12 to give you 4. So the only way that you're going to get minus 4x here is to use minus 6x plus 2. Now, use the zero factor property. We set x minus 6 equal to 0. and x is equal to 6. X plus 2 equal to 0. X equals minus 2. Now you can't have the length equal to a negative number. A length cannot be negative, so this answer is not realistic and we eliminate it. You can't have a negative solution to this problem, so the only possibility is that x is 6. So x is 6, 6 plus 2 is 8, and 6 plus 4 is 10. So the three solutions are 6, 8, and 10. Now, let's go over that. X comes out to be 6. X plus 2 is 8. So this side is 8. 6 plus 4 is 10. Now, the longest side is 10, and by the Pythagorean formula, 10 squared must equal the sum of the squares of the other two sides. So 6 squared plus 8 squared must equal 10 squared. 6 squared is 36. 8 squared is 64. 10 squared is equal to 100. So that completes our discussion of page 70.